Science is a process and a tentative body of knowledge. It also comes with attitudes of scientific skepticism where a person should have to provide evidence for a claim. Scientific skepticism is remaining open minded to claims, but saying that a person must provide persuasive evidence before they'll accept that claim. Science can also be identified by 6 scientific thinking principles, the way that scientists think. Here they are outlined with some examples. The first scientific thinking principle that we should constantly be asking ourselves, be aware of, and be mindful of is ruling out rival hypotheses. We should be asking ourselves, have important alternative explanations for the findings been excluded? When might we use this? You're reading in the newspaper and come across the headline, study shows depressed people who receive a new medicine improve more than equally depressed people who receive nothing. Well, how do we use ruling out rival hypotheses? The results of the study could be due to the fact that people who receive the medication merely expected to improve. This is referred to as the placebo effect. It's a very powerful effect that we've demonstrated, and so we need to be asking ourselves, are there other explanations? Was it the medication that led to the improvement, reducing depression in these people, or was it just they expected to get better, right? And we have advanced statistical designs and research methods that can be used to help us answer those questions. But in general, we should always be asking ourselves, the first scientific thinking principle, have alternative rival hypotheses been ruled out? The second scientific thinking principle we should constantly keep in mind is correlation versus causation. We should be asking ourselves, can we be sure that A causes B? For example, a researcher finds that people eat more ice cream on days when crimes are committed than when they aren't, and concludes that eating ice cream causes crime. Now, this obviously sounds silly, right? And we're going to talk more about correlational designs and those kind of things in the research methods chapter. But here, this researcher is claiming that there's a relationship, a correlation between, finding out that as people eat ice cream on days when there's crime. How do we use it? Well, eating ice cream, A, might not cause crime, B. Both could be due to a third factor, C, such as higher temperature. So, it's just because things are related does not mean that one caused the other. There could be a third cause that explains both of them. So whenever you hear, researchers or people talking about there's a relationship, association, a link, think this is correlation, and it could be that something else is causing them. The third scientific thinking principle is what we call falsifiability. This is asking ourselves, can the claim be disproved? For example, a self-help book claims that all human beings have an invisible energy field surrounding them that influences their moods and well-being. Well, how do we use this thinking skill? We can't design a study to disprove this claim. Saying that there's an invisible energy field, there's no way to measure that because it's invisible. So therefore, it's not scientific. It's not falsifiable. How can I measure something that doesn't exist? It's unfalsifiable. So we have to be asking ourselves about claims that are falsifiable. For example, if I said that, again, my psychotherapy is effective for depression, that is falsifiable. We could get a group of people with depression and we could randomly assign them to my treatment group and to a typical treatment used for depression, and we could see if my treatment is effective. That is falsifiable. When we start talking about things that can't be observed, then it is unfalsifiable and unscientific. The fourth scientific thinking principle to keep in mind is replicability. We should be asking ourselves, can these results be duplicated in other studies? Let's say a magazine article highlights a study that shows people who practice meditation score 50 points higher on an intelligence test than those who don't. We should be skeptical if no other scientific studies have reported the same findings. Science is about replication. What I find, other people should find in other studies, in other circumstances, and we should be revising and self-correcting. But if someone is making a claim and other people fail to find evidence for that claim, it's seeming like it's unreplicable and probably not scientific, and that should raise our internal alarms that this is a false or potentially pseudoscientific claim. Generalizability. Do these findings and conclusions reflect the diversity of the human experience? A study conducted in Iowa City, Iowa reports that young adults are more successful and independent when they live at least 50 miles away from their mothers. We should wonder whether this pattern in predominantly white individuals from a small city in the Midwest United States is likely to hold true for a population from other cultures, locations, and communities. When we have a study, we should be asking ourselves, to what degree can we expand this finding to other people throughout the world? Right? I mean, just think about the cultural variation that we have, and we talked about how this makes psychology very difficult to study. Again, if the sample that was used for the study and the population from which it was drawn is, a predominantly white Midwestern city, can we really generalize those findings to other people? Maybe, maybe not. We would need more evidence. So asking yourselves, do these findings and conclusions reflect the diversity of the human experience? That's the scientific thinking principle of generalizability. The sixth and final scientific thinking principle is extraordinary claims require extraordinary evidence. Is the evidence as strong as the claim? We should always be asking ourselves that. Let's say you come across a website that claims that a monster like Bigfoot has been living in the American Northwest for decades without being discovered by researchers. This is an extraordinary claim, right? Because how are we going to say that there is this large hominid creature, and I would argue a pretty populated area in the American Northwest, and researchers haven't found it? Why is it that just a few people pop up every now and then claiming to see Bigfoot, but apparently researchers can't find it? Why don't we have a body? If Bigfoot and these giant hominid creatures exist, why do we have no body? Now, if people were to say when Bigfoot dies, their body, just disintegrates, that would be an unfalsifiable claim, looking at scientific thinking number 3. And again, should raise our baloney detectors that these claims are probably pseudoscientific or non-scientific. So if someone's making an extraordinary claim that, X-ray vision is a thing, or that alien abductions are real, or, that Bigfoot is real, extraordinary claims, remember, require extraordinary evidence.